Hola clase. Today we are going to see how to make a quadratic equation from a table. And as usual, I will give you a how-to step-by-step guide, and then we'll make an example together. So before you starting, you need to know that quadratic equation in expanded form always is going to look the same. It looks like a x squared plus bx plus c. So for the how-to guide step by step, first, if they haven't given it to you, create a table. So you've got everything nice and tidy. Then you always check for the first order difference, and you were hoping for a constant here, but because this is a quadratic, this won't be constant. When that fails, what you do is you check your second order difference, and in this case this will be a constant, and that constant it's actually giving you some very important information that allows you to get your vertical scale. And excuse me, that should be your 3. And then after that you check for B and C, because that part is going to be the linear part. Let's see this on an example. They give me this sequence and they want me to obtain the equation that generates it. We don't have any context here, we only have the numbers. So first you need to remember that these are your results, which means they are your y, and the position in which they are, so the first one in the sequence, second, third, and so on, those are your x's, so you know where to put where. Now remember again that we may not have to write every single step once we are a bit more comfortable, but until then we're going to put everything here, make us a bit of space, and in case of doubt you always write more rather than less. So first I put my y's in place. Remember, the important thing is that everything matches, and those are the first, second, third, fourth term of the sequence. And when I check the first order difference, exactly the same as with a linear, and we would do 18 minus 9, that would give us a 9. Then we would come here, we would do 31 minus 18, that gives us a 13. That's a problem because it's not a constant. And when we do this, 48 minus 31, that gives us a 17. So that's a problem. It's not a linear. That means that we go and check our second order difference, which remember is exactly the same, but with these ones instead of with the y's. So you would come here, 13 minus 9, that is a 4. And when you do the next one, 17 minus 13, that is a 4. And that is a good thing, because now this number is constant, and that means that you know this is a quadratic equation. So the important thing now is that this constant that you got, it's twice your vertical scale, 2a, which means that in our case a equals 2, and you know that your equation is going to be 2x squared plus bx plus c. And now you're going to have to find these two. So what you do is you ask yourself, what if I only had 2x squared? So if this b and this c would be 0, what could I see? And you come here, and from here you could see a 2 times 1 squared. Not that you would write this, but that could be a 2. Then would you see a 2 times 2 squared? That could be an 8. And if you do it with a 3, that could give you an 18, and then a 32, which of course, as you can see, it's not exactly what you had. So now you look at the difference. The difference between these two values, let's call it difference here, that difference cannot come from the quadratic term. So it needs to come from b and c. So you look at what you had and make the difference with what you would like to see. So this column here minus this column here. And that's going to give you some result. It's not, or it may not have to be a constant. If we do the second one, 18 minus 8, that gives you a 9. The third one, 31 minus 18, that gives you a 13. And the fourth, 48 minus 32, that gives you a 16. So now this is telling you that B and C, or B or C, some of them are different than 0. But this term, it's a linear, and you know how to get a linear equation. So if we do it in here, then what you do is you calculate the first order difference of these results, not of your y's. You already calculated. That should be a 10, excuse me. So when we do this, we do a 10 minus 7, that gives me a 3, and we're searching for a constant. We know it's a linear. 13 minus 10, that gives me a 3 again, so things are looking good. 16 minus 13, that's a 3 as well. That's a very good thing. This constant is my b, because it would be my gradient. It's the term that goes with the x. And now I need to check to see if there is a c. So we repeat the process. We ask ourselves, what if we only had 3x? If our c would be 0, what would we see? And then we do the same. 3 times 1, that would give us a 3. 3 times 2, that would give us a 6, and so on and so on. 3 times 3 could give us a 9 and a 12. Which now again, let's use different colors. Which now again, when I compare with the linear component, it's slightly different. So I know there was a c. The c was different than 0. So I come here. Let's call it difference again. Not that the labeling really matters. But now I would check if we match the colors, what I actually see minus what I would be expecting to see if c was 0. So in our case, 7 minus 3 equals 4. And again, we only have to do one, but we're going to do them all so we see where it's coming from. 10 minus 6 gives me a 4 again, which is good, is a constant. 13 minus 9, and later on 16 minus 12. So this is the c value, that is a 4. It gets to a point in which I've got everything I need, all the pieces, so I can come here and give the equation that I was searching for. Remember the format, ax squared plus bx plus c, and I've got the a, the b, and the c, so I can come here, 2x squared plus the b, which is 3x plus 4. We've got it, so we box it so it's easy to find, and we're done. Okay, now it's your turn to go and practice. Thanks for watching.